Hello and welcome to the 6th episode of the ChessTDD screencast. This one I'm actually doing on my home machine, which isn't quite as fast as the one I use at work. So I've done a little bit of editing out dead time where I was just kind of sitting there watching the dots waiting to turn to green or red or what have you. So you might see a little hiccups here and there and things that look a little fishy. I wasn't cheating, I promise. I was just editing out literally dead time where I was sitting there doing nothing. So anyway, back to the task at hand. I'm now putting things into the list here. It was pointed out to me today that it's a little hard to read, so until I increase the font on this, I'm going to read what I'm doing. I'm saying I wish rook's get moves were a little more linky. And I've got a rook, so why not a bishop, and why not a queen, and then why not a king, and maybe even a knight, which moves a little differently. I'm going to make all those yellow, and then I'm going to set about making rooks get moves a little, more link-like, more elegant, I think. So what I'm doing is I'm looking at these two if conditions in yield return, and I've kind of been, brainstorming a little bit as I was doing this about how to make that seem a little more elegant. The first thing I'm going to do here is I'm actually going to write a test, and it's not going to be a red test, and this is okay to do. You can always write more tests. I'd feel a little bit better if I had more test cases instead of just the ones I had kind of teased out with TDD. I guess you would say this isn't strict TDD. It's more just writing unit tests, but I'm going to just add another data point in here to feel better about the refactoring I'm about to perform. And what I'm going to do is say that the get moves from method is going to return the coordinate 7, 4 if I pass in the coordinate 7, 1. So what I'm expecting here is I think the method that I've created works for pretty much any case you could dream up. It's always nice to know that. And in fact, when you're doing production code, TDD is often not going to be the end of your automated test suite. You'll write integration tests. You'll write various kinds of system and smoke tests. There are all sorts of automated tests that you can write going beyond simple test-driven development, kind of design teasing tests and documentation tests. So at any rate, I am actually putting in the test that I'm describing in the method name, where I'm going to say that here's the board coordinate 7, 1, and for the default board size of 8, I want to assert that it's true that I'm getting back a coordinate where the x coordinate is 7 and the y is 4, and sure enough, that happens. So I feel pretty good about going ahead with the refactoring now. So I'm going to take a crack at this, and I'm going to seek to make this a little more declarative, and that's one of the things you can say about LINQ is sort of like SQL. It's declarative versus imperative, which means I tell the code what I want rather than how to go about doing what I want. And that's one of the nice things about these LINQ semantics is that you're not getting lost in the actual procedural minutia. You're just saying select this, where that, etc. So I want to favor that style a little more, and in doing so, I want to demonstrate that you can go ahead and do kind of substantive refactorings when all your tests are green. So what I'm doing here is I'm defining a set of available coordinates first. If you're not familiar with this method, enumerable.range is just a way of getting a increasing list of integers. So I'm saying get me a range from 1 until whatever board size is. So in all the test cases, this is going to be 8. It's going to get you the integers 1 through 8 as an enumerable. Pretty simple stuff. So what I'm going to do now is I'm going to be selecting something I'm calling vertical moves. So what I'm going to do is I'm going to take these available coordinates, and I'm going to say that for each one of them, 1 through 8, get me the ones where the starting location's y coordinate is not equal to this thing. And then what I'm going to do is I'm going to select the starting location's x coordinate and whatever the y value is. So if I'm starting on a y value of 4, what this is saying is go get me the starting location x and then every y value that isn't 4, which is a nice descriptor of how you would actually go about getting the vertical moves if you think about it. So where am I vertically? All right, get me that x coordinate and then every other y coordinate besides this one. Now I'm basically just going to do the converse here for x, and that's going to give me horizontal moves. So this will be a little easier to kind of reason through. I just flip all the different variables, and I'm going to do a select. So I have where and select. These are LINQ semantics, very similar to SQL if you're familiar with that. So from an integer, I can actually, select a mapping from an integer to a board coordinate involving that integer, which is what I'm doing. So vertical moves and horizontal moves I have as var, but what they really are is enumerables of board coordinate. So what I'm going to do now is just return the union of the vertical moves and the horizontal moves, and union just smashes the two things together. So return all the possible vertical moves and all the horizontal moves, and now we can do a little bit of celebrating because the tests stay green. So we've done a successful refactoring. We can tick something off green on the to-do list, which is nice. And that's sort of one of the nice demonstrations of the power of test-driven development. So I got an implementation working. It was a little clunky in my opinion, but it was functional, which is really the most important thing. But then once all those tests are green, you can sort of, without any fear of causing problems, go back in and refactor. And I cannot tell you in a production code base how nice it feels to be able to look at a particular method and say, you know what, I don't like that. I've learned a better way of doing it, and I want to go with that. And I don't want to be terrified of touching this legacy code. I like the confidence of just knowing that at any point I can go in and refactor. So next up, I'm actually starting out on bishop. I don't have a bishop class yet, so that's going to be my first failing point. And I'm going to write a test here right at the get-go in order to start teasing out the existence of this class. Excuse me. So I'm going to say that bishops get moves from returns a non-empty collection. This is a rather obtuse test. It's a good starting point. It's an example of a test I may or may not cannibalize later. It requires some reasoning about whether or not there's ever a circumstance in which get moves from could return an empty collection in this case. It would be the degenerative condition of a 1-by-1 board, so I don't know that I want to address that, but that can be figured out later. This test is perhaps a candidate for cannibalization or perhaps not. It's sort of borderline. And when I say cannibalization, what I'm talking about is writing a sort of obtuse test at first to get going with your process and then actually rewriting that test to get read later instead of saving it and building up some cruft and liability of a relatively obtuse tests. This one's kind of borderline. So the actual substance of the test here is fairly self-explanatory. I'm going to pass in some board coordinate, and then I'm going to assert that it's true. Oh, and I have to include the board size, which in this class we don't have any nice constants defined yet, so I'm just going to pass in a magic number. And I'm going to assert that there are any things in this return collection. Now, this is right now failing because the method's not defined. So in this case, I actually did something interesting. The easiest way to get this test to pass for me, by my way of thinking, is I know that this is going to inherit from piece. So all in one shot with the IDE tools, I can say, hey, go inherit the piece class. And I'm actually getting a nice definition in here of this IEnumerable method, this override. So to me, that's actually easier than defining it by hand and then later figuring out a way to tease out the inheritance. This is great. So I've defined that, and I just have to get it returning something reasonable. And I can do that by using enumerable.repeat once, and I'm just going to return any old board coordinate, and that should get my test to pass. And any moment now, I would expect that to pass, so I'm actually just going to kind of speculatively pipeline ahead, and yeah, there's the passing. So no harm, no foul. If I were to start kind of doing work while waiting for the machine to catch up, especially for those of you that have slower machines, you can do that, but make sure that if it doesn't actually go green after a while, you stop and check, because you don't want to be writing new tests when old ones are red. It's important in the red-green refactor cycle to always make sure your code is doing what you expect it to. It should go red when you expect it to go red. It should go green when you expect it to go green. Either one of those things not happening when you expect it to is a problem because your code's not doing what you expect it to. That's not good. The whole point of this style of development with the fast feedback loop is to make sure that you can always reason about your code at compile time, that you don't need to fire up the application and see what happens in order to know what your code is going to do. You want to be able to reason about it as it's written. So now we've got to take the next step in making this method not stupid. So if we pass in 1-1 to bishop, we should expect that 2-2 is returned. Bishops move diagonally, in case you hadn't gathered that or weren't aware how the game of chess works. So one thing I'm going to do is I'm going to note here that I'm going to have the same default board size for a lot of tests. And I don't just mean here where I define a constant in rook, and I'm maybe going to define another one here. I mean, I want to make a note in here so I remember that, do I really want to define the same constant over and over again in a whole bunch of tests, or maybe do I want to have these unit tests inherit from some common class, or refer to some globals.cs or something? I don't know. I'll figure that out later. That's the beauty of this process. I can solve the problem I'm trying to solve right now, and then solve another problem later. Now, the way I solved this, the simplest way to solve the most recently written unit test was just to change what it was returning. So in both cases, returning the board coordinate 2, 2 makes both of my existing tests pass. Well, that's pretty stupid, but they're both valid tests and they're both passing, so I won't discard them. But what I will do is, before I actually write the meat of this test, I'm going to do my usual refactoring here, which you've gotten to know by now, where I'm going to define target, and I'm going to get rid of this redundant instantiation. And I'm clued in to do that. You'll probably see this a lot, where I actually start typing the test, and then I think to myself, okay, I want to type target now. I don't want to redo this instantiation logic. So usually, rather than right after a test, I start to think of this when I'm writing that third test, like, hey, let's get rid of this duplication. And it's perfectly fine to do that. The existence of this obtuse test that doesn't have any code in it, everything's still green. I mean, speaking of degenerative cases that I mentioned earlier, a unit test with no code in it is a degenerative passing case, trivially always going to pass. So everything's green. I can refactor. And that's exactly what I'm going to do. I'm going to remove this bishop, and I'm going to put in target. And I'm going to do the same thing in this next test. And once I get done, I have to make sure that I'm verifying everything goes green, that I'm avoiding non-compiling. And it sure looks like everything's going green. Oh, yeah, there we go. I probably need to get rid of null dereference. I stand corrected. Everything wouldn't have gone green if I hadn't kept typing, but now it's good. So everything is looking green, and I'm also going to define this default board size of 8, and I'm going to quickly slap that in here for these so I get rid of the magic number. And then I want to verify that everything's passing. I see a black dot up there. That's not good. I want that to go green. It's fine to type, but, make sure that, there we go, now it's green. So again, if you're using the continuous testing tool, this applies to you. If you're pipelining like that, if you're kind of speculatively coding, always make sure that what's happening is what you expect. Check back from time to time. If you're not using a continuous testing tool, I feel really sorry for you. This is indispensable to me. I highly recommend it. Did a Pluralsight course on it. It's worth the money if you can get your organization to pay for it. Quite frankly, even if I couldn't, I would just buy it out of my own pocket. All right, so next up, this is going to drive me to write something that's not trivial. I'm saying here that for 2, 2 being passed in, it should now return 1, 1. So I can't get away with any quick hacks to make this pass. I mean, I guess I could put in some kind of silly if condition, but when you're doing the simplest thing to make your code pass, what you don't want to do is get into a situation where you're just defining a bunch of hard-coded if kind of things that you're not doing yourself any favors. The simplest thing you can do to make your code pass while progressing towards your goal. So this is not a great algorithm yet, but what I'm doing here is I'm saying that for every integer 1 up to the board size, I'm going to return a board coordinate of n and that n. And I think my IE went briefly nuts on me here. I remember editing out a bit. Anyway, what you're seeing there, that null followed by the equals and greater than sign, was the result of an autofill. If you type n with CodeRush, it'll fill in null. I just kind of left it as I was typing, knowing that I'd slide back over and change that to n, so don't think putting null there isn't a valid thing to do, but putting an n there sure is. So what I'm doing now is I'm returning 1, 1, 2, 2, 3, 3, etc. And that's actually going to satisfy, once you'll see the dots go green, that's going to satisfy what we've written so far. So now when I think about what a bishop does, it doesn't just move along those specific squares on the board. It actually has to move in any diagonal direction that's valid. So I have to break out of this better but still obtuse case by saying, all right, so if I pass it 1, 2, I should get back 2, 1. That's not on this predefined diagonal. So I'm going to have to do better than what I currently have in this test. And really, when it comes to test-driven development, that's kind of how I think of it all the time. Let's always do a little bit better. All we have to solve is this current problem that's in front of us. We don't have to worry about getting it right or all the edge conditions or anything like that. That's, for next test. We'll worry about that in 2 or 3 minutes. Let's just worry about getting this test to pass. And I might add, just as importantly, we have to worry about not regressing, not breaking any of the previously passing tests by making this new one pass. So I'm pretty well out of options here. I'm going to have to start looping, and I usually try to avoid or keep control flow structures as simple as possible. You're not going to write a piece of code without having loops in it, but don't do that until you need to. So I am going to do that here. Sometimes if I don't know immediately off the top of my head what I'm going to write exactly, I start with a loop, even in a situation where maybe there's some kind of LINQ magic we can do. If you're watching this and you're not a C# programmer, if you're doing something like Java, I don't think that you've got anything quite like LINQ in Java. I know that there's recently been closures and Lambda expressions introduced. I haven't kept up on that too carefully. LINQ is pretty powerful. If you don't have it, I guess you can disregard some of this LINQ foo that I'm doing here. And the same principle applies. It'll actually probably help you to watch me type these out with loops. So when I'm not sure what I'm doing, I fall back to old habits and say, okay, I'm gonna define a loop and then I'll linkify it later. So what I'm doing here, what I kind of figured out as I was typing along, is that if you think about what a bishop actually does, you could represent this. It might not be the most efficient or optimal way to do this, but you can represent it by radiating outwards 1, 2, 3 on up to board size in every direction. So what I'm going to do is I'm going to define 4 of these things that I'm going to add to this moves collection I'll eventually return, and I'm going to loop through incrementing index by 1, and index is going to be the 1/1 distance from the starting square. So I'm going over 1, up 1, and then over 1, down 1, and then back 1, up 1, and back 1, down 1. And I'm viewing that as a way to get all of the possible moves from wherever we start on up to board size. That's actually going to be a superset of what we really want, because what you're probably noticing is that if we start at 1, 1, this is going to return a lot of things like -6, -6. So I want to put in here that this does not return negative values. I don't want this returning stupid or impossible things. So I'm going to say it does not return negative values for board coordinates. And that's something that kept happening in my IDE while I was typing this that I probably need to look into, that test attribute thing. Anyway, what I'm going to do now is just define the actual method needed in order to test this. So I'm going to assert that it's false, that if I do a target and I get moves from a board coordinate that's, valid, whatever board coordinate, and then I pass in the default board size, when I do this, I shouldn't be getting back any negative board coordinates. In fact, I shouldn't be getting back any 0 board coordinates, so it might have not hurted to give this test a slightly more strict name. So once I get this defined, saying that there's no board coordinates with either a x or y value less than 0, and again, I could have made that less than or equal to 0, I will go back and fix the fact that this got auto-corrected to that attribute's target, and then we'll have a valid failing unit test. There it goes. So now what I have to do is go and fix this, and I did a little bit of playing because things are about to get ugly here. Because what I'm going to have to do is extract this out, and I'm going to have to give this coordinate a name, and then I'm going to have to do an if condition check on it. So I'm going to call this up 1 over 1. And then I'm going to go down and I'm going to say that if up 1 over 1 is valid, which is a method we had defined in an earlier iteration of this, that if it's valid for this board size, then add it. And that's a method defined on the actual board coordinate itself, we already have logic in place for discarding 0 or negative values. So I highlighted that and I wanted to do some extraction here. And that's a little iffy. You might consider that a refactoring. I didn't wind up doing it because it's too many parameters and not pretty anyway. But so to do this or not to do this while trying to get a red test green, the reason I thought to do it at first was because I thought I was going to have to type a lot of repetitive code. And if I could define a single nice method, get moves from extracted, then it would actually be easier to do that for the remaining 3 conditions than it is to extract a local and then define that if condition. So in my opinion, at least in my travels with test-driven development, there are places where you might do, I don't know if I'd call it a refactoring exactly, but you might do an extraction of a method as actually the simplest way to get something to pass. If you're going to do the same operation on a bunch of code, if you look at what I'm about to do here, it's kind of unpleasant. I'm going to have to do another pulling out of this board coordinate, and I'm going to have to keep doing that over and over again. So you can see here I was trying to figure out a similar sort of thing. Can I, extract all of this somewhere? I have sort of an aversion in general to multiple control flow structures in the same method. To me, if there's a for loop, I should pull out all of its contents and extract those into another method. I tend to prefer all of my methods to be of the form some statements and then maybe an if or maybe a for or a while, but not more than that. I don't like nested control flow structures. It starts to result in a lot of flags that are hard to follow. The methods get long, things get hard to keep track of. You have multiple return points. It's not ideal as far as I'm concerned. So here I'm laboring through this down 1 over 1, and I'm going to add it only if it's valid, and I'm going to keep on doing that. Extract, check, add. And as I'm doing that, I'm sort of cringing because this is not elegant. I don't like this code. And so I'm not going to do it this time, but I know that one of the first things up on the docket for the next time around is to find a way to make this method not so ugly. Now, I'll say this. What we're about to do here, once this goes green, this is shippable code. It's going to satisfy all the conditions, and if you're looking for a minimum viable product and your business needs to deliver something to market, go ahead and ship this, and I'll tell you why. It's because you've got this nice suite of tests around it that you can come back later and say, you know what, when there's more time, I can come back and polish this thing. I can make this more linkified, or I can extract methods or restructure it so that it's a lot more readable. You're giving yourself the freedom to do that later by covering it with unit tests. You don't have the unit tests, I promise you, once you ship this thing, once it's working, you're never going to want to touch it again. Why would you? It's working code, and you're running the risk of making it not working code if you touch it. Nobody wants to do that. That's why people are afraid of legacy code. So to me, once I became practiced and fast at doing test-driven development, you can still get to non-ideal methods. You can still have that kind of, we got to get it done, we got to ship, without sacrificing test coverage. That's what I have here. Not the greatest method on earth, but I think everything's about to go green, and then life's pretty good. We're going to consider that at this time a good place to stop and maybe go back and revisit what's going on the spreadsheet before we finish up here. So I'm looking at a large method, but one that's completely green, so I'm pretty happy. I consider this to be a good stopping point. Looking at this bishop class, hey, we've got bishop. It works. It's not the greatest, but it works. So I'm going to color this green. And then what I'm going to do is I'm going to insert some things I want to make note of here that I kind of want to loosely do before I get around to queen. I'll read them off again as I put them in here for people who are having trouble reading with this small font. And again, my apologies. I will fix that next time. So I'm going to say that at some point, we should probably add additional tests on bishop. Maybe, we haven't fleshed this out enough, but we'll see. And the other thing I want to do is refactor this method, obviously. It's pretty ugly. And so we'll call it a wrap from here. So I will see you next time around. Thanks for watching.